Well, hello everyone. I guess the video got cut off in the middle, but it's okay. The show must go on. Good morning, good afternoon, good evening, wherever you are in the part of the world. I hope you have a very good and pleasant day today. It's in the middle of the week. It's quite extraordinary for You Inspire Alliance, especially to have a special slot to talk about from what our youth perspective, youth and young professional perspective, because it is happening in the middle of the week. Usually we did our previous talks in during the weekends, but because of the topic is special today, it's related to the water. I would like to greet our fellows that related to water, and also young and professional who has the same interest in terms of water that related also with a disaster. I would like to also to tell you that we're going to have three young professionals, and they're going to share their experience, their views on cross-sectional topics. I'll let them going to introduce their insight. Before I proceed for the first one, let me introduce a little bit background of our first speaker. The first speaker is actually from You Inspire Malaysia. Her name is Nur Zaihan. Nur Zaihan is actually a young researcher that aims to complete her PhD research on disaster management in heritage conservation with a high impact contribution for the industry and community. She had received her degree in interior architecture from University Technology Mara, Malaysia, and recently just completed her master education with first class award, major in construction project management. As a trained in interior architecture, she has unique 10 years experience in communication, elegant leadership, strategic planning, project management in multiple development projects from medium to high scale projects that actually encouraged her to establish her own interior design firm in 2017. With the topic that she's going to share on us, the nightmare that never faded, tsunami in Malaysia, I please welcome Nur Zaihan to have the floor. Thank you.
Thank you, Latifa, our Miss Moderator for today's. And thank you for You Inspire Alliance for inviting me to be one of the speakers to share on my topics today. Basically, I'm with You Inspire for, I think, 1 year plus, not that long, but they really teach me and open my eyes on how important of the disaster risk reduction. And coincidentally, it's actually have something to do with my experience with the disaster also, which is 2004 tsunami, the Indian Ocean tsunami. So for today, I will share a very surface or not that very technical details on the facts of the 2004 tsunami in Malaysia. But first, let me share the videos. I have one videos to share before I start with my talk. I hope my screen is visible.
Yes, we can see the screen.
Okay.
Is there supposed to be a sound? I don't think we can hear any sound.
Okay, what you just saw, what you just watched just now is actually the videos I retrieved from the YouTube on what is actually happened on the 26th of December 2004 in Batu Ferringhi, Penang, Malaysia. So I will share with my slide first. So from the videos that I showed just now, you can see that how they have a lacking of awareness, and they didn't know that it's actually to be the worst disaster that happened not only in Malaysia but also in the world, which is, we name it as a tsunami. You can see that the children are very happy and very, it's like they are welcoming, they are waiting for the wave to reach the shore. However, they didn't know that it will cause a very huge impact, which is causing a death and everything to the humans. So this is what is actually happening to most of the people in Malaysia, where we never experienced this kind of tsunami. And even that is actually what is my personal reaction. We saw that wave, the white color wave that approaching the seashore, and we didn't run. However, we didn't run, and we keep waiting there until the wave hit the shores, and only by the time we know that it is not a normal wave, and it is actually a very dangerous wave, which is tsunami. So this is why I decided to share on this, which is a mixture of the facts and also my own experience as one of the tsunami survivor in Malaysia. So as you know, on the 26th December, which is in the early morning of the Sundays, right after the Christmas night, a very massive tsunami hit 14 countries, which is actually caused by a very bad earthquake, which is the epicenter in the Indian Ocean, which is nearby the Banda Aceh. And in overall, is actually the tsunami caused over 280,000 deaths worldwide, affected 40 countries, including Indonesia, Malaysia, Thailand, India, Maldives, Sri Lanka, and South Africa, and there are several more countries. And in Banda Aceh, which is the worst or the most affected areas caused by this tsunami, in Banda Aceh itself, it claims over 170,000 lives. And the wave is actually goes to up to 30 meters wave height, which for me personally, what I have seen in Penang, which is in my hometown, I managed to witness is the wave height is around 8 to 10 meters high, which is higher than the coconut trees. And from the fact also, it stated that the wave speed is actually 500 miles per hour. So that is the reason why how the tsunami can sweep away even the Banda Aceh itself. This is the statement that I retrieved from the news, which is, I had never seen such a wave. I knew something was wrong as the waves was dark and as high as the coconut tree. This is a statement from the ice cream seller at Teluk Bahang Beach, Penang in Malaysia, where Teluk Bahang also one of the affected areas. And there is also victims in this Teluk Bahang Beach, mostly among the pinnacles and also the children's, because they are playing at the beach. They don't know what is actually happening, and they were swept away by the tsunami. So these are the headlines in Malaysian newspapers. You can see that it becomes a main headlines for for over a few days, wave of deaths, the tidal wave devastation, and so on, because nobody in Malaysia, even in the world, are expecting on this. As a Malaysian country, which is we are not prone to a major natural disaster. This 2004 tsunami is actually one of the nightmare that will never be faded in every single person of the Malaysian people. And these are just a collecting. If you can see the right photos, these are the view of from I think it's from the condominium in Penang, in Pulau Pinang, one state in Malaysia. The tsunami wave spotted in Tanjung Tokong. If you can see, they can see the wave is actually approaching the beach. So this is one of the photos that we can see as of today, because in the 2004, the smartphones, the high resolution photo is still very rare item, at that time. So wherever that we have, the photos might not be in a good resolutions. Even the footage of the incident also not in a very good resolution. But however, the incident is stick in the mind of the Malaysian people up until today, and we can clearly remember how it's happened. So you can see these are the timelines, which is the first earthquake with on the 7:59 a.m. Me myself, I experienced it because I live at the two-story flat. So my house is at the top level. So I can clearly remember how we feel very dizzy at that time. And when I look out the windows, I see all the residents already went outside of their house, because they say they feel something, a very strong shaking. So you can see there's a gap, a few hours gap before the first wave of tsunami hit the Penang or the Malaysian coastal around 1:15 p.m. During the first wave, I'm not at the beach yet, because the wave, we just get the information, there are big wave, a very big wave hit the shore. And you can see there's around 15 minutes to 30 minutes before the second and the third wave, which is the most severe or the most worst wave that hit Malaysian coastal at the time. So I only reached the beach and I saw the second and the third tsunami wave, which is we also been swept away by the second wave. And luckily, we managed to grab on something like the house fence and something, and even my late grandfather also been thrown away by the wave and managed to grab the coconut trees. So that's how the incidents is stuck in my head even until now. It was a very, very, I don't know how to say, it's a very chaos. There's a lot of people at the beach at that time because they want to wait for the second wave. They thought it's a normal wave. Unknowingly, the second wave is actually even worse and could kill us. So the second and the third wave is like what I say is around 8 to 10 meters high wave. And in Malaysia itself, we have around 67 deaths, which is the most death is in Penang, which is my hometown. And one, not only one, actually 5 out of the 52 that is actually my own relative. It's the children's, because they are playing at the beach at that time and they were swept by the tsunami. And we can see that a lot of videos that you can watch in the YouTube showing that or you being questioning why they keep recording on the wave when they know it's something is not right. Why the parents didn't call the children to come to the safer place? Why they allow the children keep playing at the beach? you know, from this statement itself, you know that nobody knows what is actually happening. In an instant, the situation became chaotic. And this is actually a statement from Mr. Supia, a father of the miracle float baby, where during the tsunami, his baby, which is a 22 days old baby, was swept away by the tsunami first wave. And luckily, with the God bless, the baby was swept or bring back to the shore by the second wave. And that's how the baby survived. So even Mr. Supia, until today, there are Penang people, they still doing a bless or like a offering to the ocean to thank to the God for giving this miracle by saving his babies at the time. These are actually the collective of photos that I get from the internet. I think by this photo itself, you can see that how from the photos number 1, you never know that this kind of wave, the white bubble wave, will harm you. And you can see the chronology until this the number 6 photos, how it can actually damage the whole the beach side of the houses, you know. And these are the damages. On the left, the fourth photo in the left is the in Penang. And what you can see on the first photo, which is you can see there's a zinc, a blue zinc. Now that area, they already plant a mangrove barrier along the roads because of this tsunami. Actually, the original plan, they want to do something. They are reclaiming the land and they want to build, I forgot why is it, maybe to want to do a waterfront or something. But because of this tsunami, they changed the plan and they plant the mangrove barrier across the road. And you can see there's a lot of damages. The fisherman's village being destroyed. The vehicles that parked alongside of the roads also being swept by the sea. And because of this, tsunami is actually opened a lot of people's eyes, not only the population itself, but also the local authorities and the government itself. So because of this, it leads to the establishment of the National Committee for Tsunami Early Warning System. And then also up to today, there are 50 warning systems installed nationwide, especially at the area that affected by the tsunami previously, and also increasing of awareness on importance of mangrove barrier for the coastal area. So what I could say that the awareness is there in Malaysia, but it's not at a very high level. So this is where all the researchers in Malaysia and also the national, international researchers are doing their best to come up with a lot of research to increase the awareness on the natural disasters, and they are making the knowledge sharing within each of these countries. Like what You Inspire did now, we have a lot of You Inspire chapters where we can share all the knowledge on how we want to fight or how we want to recover from this natural disaster impact. It is very important also for the professionals like us to bring this awareness or to bring this knowledge to the local people, because from what we can see, the first video that I show you, they are normal people, have no awareness, have no knowledge on the natural disaster like tsunamis, and that's how they might get killed because they are waiting on the danger itself. So this will be the end of my presentation, because to be honest, when I prepare this slides is like less than 10 slides, but it's really touched my heart, because I have, even myself have the what we say, the post or the impact, psychologically impact by the tsunami 2004, where previously, because my house is just behind is the sea, I can go swim there every day. I am very champion. I was 14 years old. I was grow up at the sea area. I can swim every day, but because of that tsunami, until today, I cannot swim. That will be, I don't know, because of the psychological. I never speak about this until I met Dr. Rahma and everyone from the U-Inspire in the GP-DRR in Bali last May, where I openly speak about my experience in tsunami. And they encouraged me to share about this openly in today's webinar. So I hope that my personal sharing and on what happens in Malaysia and also what I have experienced myself could bring some awareness or could open eyes in everyone's to be more concerned and be more realistic after this. Don't wait for the wave. Have to be precautious in everything that we saw afterwards. Okay, so that's all. Thank you.
Thank you, Nur Zaihan, for what touching and on your experience and also your insights that you've been experienced. For those who have questions or maybe would like to share your experience as well, you can do so by clicking and typing on our chat box. And then maybe if there's any question, we will keep your question to the end of the session, and then we will ask to the respective speakers. With that, thank you very much, Nur Zaihan. I would like to move for this next speaker. We have in-house is actually who just got back from the UK, Miss Giovanni. I've known Giovanni for quite a few years from now, but today is the first time that I'm going to learn what she's going to share about. So Giovanni is actually a MSc candidate in Risk and Disaster Science from UCL. She just finished a master's study at Institute of Risk and Disaster Reduction. UCL stands for University College London. So she is also a member of U-Inspire Indonesia and previously worked at a research center for disaster mitigation, Institute Technology of Bandung. Her work surrounds of GIS and disaster risk reduction on earthquake and tsunami. So we have one of the young professionals who has insight that towards water related. So with the title of Agent-Based Tsunami Evacuation Model in Tanjung Benoa Village, Bali, Indonesia, I give the floor to you, Giovanni. Please welcome.
Okay, thank you, Kaifa. Can everyone hear me?
Yes, loud and clear.
Yeah. Okay, thank you, Kaifa, for the opportunity and for the short introduction. My name is Giovanni. I just finished my master study at University College London. So today I'm going to share to you my thesis. Actually, this is my thesis. So the title is Agent-Based Tsunami Evacuation Model in Tanjung Benoa Village, Bali, Indonesia. So I'll be sharing about the background and the aim of the study, and the components of the agent-based tsunami evacuation model, starting from the data until the process and the limitation and the results. And I will close it with conclusion and recommendation. Okay, so I think it's a bit obvious that Indonesia is one of the countries that prone to several natural hazards. And today I will focus on tsunami, as we know that there were major historical tsunami events happen in Indonesia, followed with huge casualties and economic loss. For example, the 2004 Aceh tsunami that already explained by Kaan, and then 2006 Pangandaran tsunami and other huge tsunamis. And it happened and causing a lot of casualties due to lack of awareness and preparedness. Because if we see from other countries such as Japan, for example, who experienced also big tsunami, but they have more preparedness, so the risk is less than compared to Indonesia. And we can also found that in Japan, for example, the evacuation plan is very well prepared. So we can see that evacuation is one of the most effective ways to save life. And unfortunately, in Indonesia, there's still limited studies about tsunami evacuation. So that's what triggered me to do this as my thesis. So the aim of this study is to apply the agent-based model for tsunami evacuation simulation through the integration of the tsunami hazard modeling, the people behavior, that's the decision making for the people, and then integrate it with the spatial data using GIS. And for the area, I choose Tanjung Benoa village in Bali, Indonesia. It's because Bali is one of the islands that is famous with tourists, and there are a lot of tourists there, but it is also located near the megathrust zone. And if we see from the map here, the rectangular plate underneath the island is the megathrust zone, and the yellow box is the study area of this research, which is Tanjung Benoa village. And also previously, I joined a research team with several members of U-Inspire Indonesia and the university, like ITB, and the local authorities in Bali to do the research about evacuation in Tanjung Benoa. And therefore, I continue it as my thesis by doing the agent-based tsunami evacuation model. Okay, so basically, agent-based model is one of the approach to simulate the movement of the agent behavior, the agent decision-making, and integrate it with the hazard. And in this case, is the tsunami. So we make the term as the agent-based tsunami evacuation model by integrating those 4 components. Those are tsunami hazard modeling, and then the agent behavior, including what is the evacuation mode, the evacuation speed, and then the departure time, and then combine it with the spatial data set, such as the road network, the population, and then the shelter locations. And then we also make a set of rules and scenario for this simulation. And from this agent-based tsunami evacuation model, the results will be the casualty rate estimation, and also the mean evacuation time, and we can also detect the traffic congestion. Okay, so to start with, I started with doing the tsunami hazard modeling by doing the numerical simulations. But before that, I decided to choose the scenario. So the scenario is using the megathrust Sumba or megathrust Bali with the maximum earthquake is 9 in this case. I took it from the National Study Center of Indonesia, or we call it PUSGEN. They published this in 2017, and that's why I choose this publication as the input of the scenario. And also the earthquake and fault parameters, I took it from USGS as well. And I do this numerical simulations using COMCOD, if anyone ever heard it. So the data preparation include the bathymetry data and topography data, which derived from the BIG or Indonesia Geospatial Agency. And then the earthquake source, I took it from USGS and PUSGEN Indonesia, and several softwares used in these numerical simulations. And as you can see here, this is the results of the numerical simulations for 1 hour, and the data record every 30 seconds. So you can see here the simulation of the tsunami model in Tanjung Benoa village. As you can see here, that almost the entire area are inundated with the tsunami wave. And we can also see that the first wave is arriving around 15 to 20 minutes, and the highest wave is around 40 meters. And you can see here that the eastern part of the village is struck with the highest tsunami wave, indicated with the red color. So if I capture it for every 15 minutes, you can see it in the right side of the slide. And the results of these numerical simulations, I will use it as the input for the agent-based tsunami model later. Okay, now we already got the tsunami hazard model. Now we can prepare another data, which is the people behavior. So for my thesis, I want to get the realistic response from the people in Tanjung Benoa. Therefore, I did survey, but I didn't do it by myself because I was in London. So I asked the local surveyor in Bali to help me to share the questionnaires. So there was 21 questions, multiple choices and short answer, asking about the tsunami preparedness, the awareness, and also their response about tsunami evacuation. And I chose 300 respondents in Tanjung Benoa. Those are adults only, without vulnerable people, because it's a bit difficult to get the research ethics from the university. Then I do it, and I did the research, the survey for around a month in July. And from 21 questions, at least these 4 questions are used as the input for the agent-based model. Like, we ask them, when they hear the tsunami siren to evacuate, are they going to evacuate or not? And we found that 93% of them will evacuate, but I also found that 7% of them choose to not evacuate. And when they were asked about evacuation mode, are they going to evacuate by foot or by vehicles? I found that 87.7% will choose to evacuate by foot. They choose it by running or fast walking or walking. And then 12.3% of them will choose to evacuate by vehicle. And in this case, most of them will choose to evacuate by motorbikes. And regarding the evacuation departure time, like, I asked them, if you were asked to evacuate and the government or the authorities ask you to evacuate, at what time you will start to evacuate? And it's interesting because in this scenario, I told them that, for example, if the government send the warning at 5 minutes after the earthquake to evacuate, at what time you will start to run or to find another safe zone? And I found that 40% of them will evacuate right after they receive the warning from the government, which is at minute 5. But also 36% of the respondents choose to evacuate immediately right after the earthquake without waiting for any warning. And I also found that 19% of them will evacuate later. And also we can find that here 2.7% still choose not to evacuate, even though they already received the warning from the government. And I also asked the local surveyor to measure the evacuation speed by running and using the vehicle. So this is the data from the local survey. And these inputs, I will use it as the input for the agent behavior in the agent-based model. Okay, and now I prepared the shelter locations. So actually in Tanjung Benoa, the government haven't built any tsunami shelters, but they already make agreements, or MOU, we call it, Memorandum of Understanding, with several hotels, especially the hotels who has like 4 floors or more. So they are all agreed to be used as the tsunami evacuation shelter later if tsunami happen. So these are the 7 hotels in Tanjung Benoa village. You can see it on the map. And we can see here that most of the tsunami shelters, or in this case are the hotels, are located in the eastern part of the island. And we see, if you remember the tsunami model before, the highest wave arriving in the eastern part. So yeah, it could be one of the recommendations later. And also the capacity, since this is only a hotel, so they are not prepared for the tsunami shelter starting from the other floor. So the capacity is very, very low compared to the population, because the population there is almost 6,000, but the capacity is only it's only 2,600. It's excluded the tourists. So we can imagine if there are tourists there will be need more shelters capacity. And then after preparing the tsunami hazard, the people behavior, the decision making, and then the shelter locations, I combine it together in this agent-based tsunami evacuation model, but I did not create the code by myself. The model was adapted using the previous study from Mustafizi, and then I adjusted using only what I need in this study. And the tsunami inundation, I use it from the numerical simulations before, and then the input for the percentage of the pedestrian, the percentage of the vehicles, I use it from the people behavior survey from Tanjung Benua, and then the speed also, and then the spatial data are prepared. I download it from the OpenStreetMap, such as for the road network. And then for the populations, I digitize it manually and randomly. And I use the scenario that this happened during weekend on the day. So everyone is there, everyone is around, is outside. So yeah, I place it randomly, but I also consulted with the local survey there, which area has more dense population. So I place it, the dense population there, and the least population, I will digitize it manually as well. So we can see here on the top right, the dense populations are located on the northern part of the village. Yeah, okay. This is the interface of the agent-based model. I hope you can see that this is the time. This shows the time, and when it shows minutes 4 or 5, people will start to evacuate. The brown color is the people, so we call it as agent. And I already set the rules here, like how many pedestrian, how many vehicle user, the speed for the pedestrian, the car, and then also the interface can show the percentage of the casualties, the percentage of evacuated people, and the mean evacuation time. As we see, as you can see here, that people are starting to evacuate. And if you see, the purple color indicates there were traffic congestion there. So that's why they get slower to reach the tsunami shelters area. And now the tsunami is starting to arrive. And you can see that the yellow color indicates the tsunami shelter. So basically the agent are set to run and to go to the nearest shelter. And if you see red color, so red color indicates casualties. So I assume that when people did not manage to go to the shelter area, and when the tsunami hit, so I assume it is a casualty. So actually only below 30 minutes, all the entire area already inundated with the tsunami. So we can get the red color that indicates casualties here. And this model also shows the percentage of how many casualty or mortality, which is 7.7%, and how many people are make it to evacuate. It's around 92%. Higher. And actually there are second wave, but as we know that it only needs 30 minutes to sweep all the entire village by the tsunami. I will just move it later. So these are the results of the modeling, like starting from the numerical simulations. We have that the estimated time arrival of tsunami is around 15 to 20 minutes. And this is consistent with the previous study from Ibu Rahma and Kanurul and other researchers before. And the maximum tsunami wave is 14 meters. And the results of the people behavior survey, I found that in general, they are already aware that they are living in a tsunami prone area. But if we ask them what evacuation mode, most of them will choose to evacuate by foot, but still we found that 12% will choose to evacuate using vehicle, both motorbikes or cars. And for the departure time, mostly they will choose to evacuate right after they receive the warning from the government, which is 5 minutes after the earthquake in this scenario. And for the shelter capacity, it's only half of the population, excluded the tourists. And for the agent-based tsunami evacuation model using all those scenarios, I found that the casualty rate estimation is around 7% of the population, and the mean evacuation time is 11 minutes to reach the nearest tsunami shelter. And the traffic congestion in the northern part of the village, if you remember that the red color at the model are located in the northern part. But also, as this thesis is only like for 3 months. So there are several limitations in this study. Like, for example, the numerical tsunami simulation neglects the effect of the roughness and the topography of the study area. So it's the simplest numerical simulation of tsunami. And then for the people behavior, I only targeted the adults without considering the vulnerable people. And I also did not include the young age. It is because the complexities of getting the research ethics from the university at that time. And for the agent-based model, this agent-based model, actually, this is the simplest model that I used because it's only focused on the tsunami inundation, neglecting the damage of the earthquake, the damage of the tsunami, the debris. I did not consider about that. And the model also neglect the tiredness and the change of speed of the agents. And also the shelter capacity. I did not include the number of shelter because the complexity of the modeling. And also, once I got the results using the initial scenarios, I also did some variation of the scenarios. What if all the people using the vehicles, what if only 25% of the population evacuate by foot? What if is it 50-50 and others? So you can see here that they show different results. They show different graph as well. So that means that different decision will lead to different evacuation model, and including the percentage of the casualty rate estimation, and then the percentage of how many people or how many vehicles are evacuated, and how many and where is the traffic congestion when we run the model. Yeah, that's the variation of the scenarios. So now I can give the conclusion that tsunami evacuation model is important, as we know that it could visualize the simulation better, so we can understand the hazard, the vulnerability, the exposure, and the capacity during emergency. And using the agent-based tsunami evacuation model can help to simulate the tsunami evacuation in emergent phenomenon, and doing this by integrating the tsunami modeling, the people behavior, the spatial data, and the set of rules. But I also want to give the recommendations that the tsunami preparedness efforts may not be sufficient unless the government also adds another vertical tsunami shelters, especially they can focus to build the tsunami shelters in Tanjung Benoa with enough capacity to reduce the risk of casualties. And also further studies are still needed to create better simulation. Okay, that's it. Thank you.
Thank you, Gio. Exactly on time. That's great. From what I've heard that you presented is a very comprehensive, very interesting on the topic that you're presenting. What triggers me is the bathymetry data. So I'm social scientist. So when you talk about the hard scientists like that, it's really interesting because when we talk about in ASEAN countries, especially because we surrounded by water ocean, so we have at least part of our countries at least touch the water surface, especially in the coastal cities, that we need to have the data that you simulate in order to have proper action, like also that you said, you also recommended. So basically you already took all my questions that I'm going to address to you, but it's okay. I have another questions preparing at the end of the session. But for the audience here, if you have anything that you would like to ask from the images that you just see, maybe you can ask away in the chat box. Thank you again, Gio, for very insightful, very I would say very deep to know that. And we actually going to shift to another slightly in different angle. This one I think is more technical, more scientific, but please bear with us because I'm going to introduce our we actually saved the last for the best. no, the best for the last, something like that. So, but our final speaker is we known as Angelica. She's going to present about the application of a semi-physical tropical cyclone rainfall model in South Korea to estimate tropical cyclone rainfall risk. So we heard tsunamis from two previous speakers. Now we're going to shape a little bit different. Before I give the floor to Angelica, I would like to also to read her short bio. 1 second. So, hang on. It does not appearing. As from Angelica, is actually Asia Water Council young professional. Engineer Angelica hails from the southeastern part of the Philippines. She is currently pursuing her PhD in water resources engineering at Gwangju National University in Cheonan, South Korea. Her study focused on tropical and non-tropical cyclone events in South Korea and the Philippines using statistical modeling and analysis. She is an alumni of the University of San Carlos in Cebu City, Philippines, where she graduated cum laude in Bachelor of Science in Civil Engineering in 2018. She obtained her Master of Science in Civil and Environmental Engineering, majoring in Water Resource Engineering at Gwangju National University. This was awarded after her presenting her thesis entitled A Hydrologic Essay on a Climatic Mechanism-Based Analysis, Heterogeneous Consideration of Tropical Cyclone and Non-Tropical Cyclone Impacts on Precipitation and Stream Flow over South Korea. Big words, I know, please bear with us. She has also presented at various conferences and published several scientific papers while doing her graduate degree. So with that, I would like to welcome the floor. Angelica, it's yours now.
No. Thank you, Dr. Aifa. Also, thank you, U-Inspire Alliance, for inviting me to talk today. I just want to apologize in advance because like the camera angle is a bit weird right now because my camera is actually on the keyboard. So it looks weird.
Well, we can see that you're still beautiful, so it doesn't matter. It's good.
Thank you.
You're doing good.
So again, I'm Angelica Alcantara, a PhD student from Gwangju National University. And I'm also a member of the AWC-YP, Asia Water Council Young Professionals. And today I'm going to be presenting about my study entitled Application of the Semi-Physical Tropical Cyclone Rainfall Model in South Korea to estimate tropical cyclone rainfall risk. So let me start my my talk by presenting an example of one of the major, if not the most major, tropical cyclone event in South Korea. So I think most of you guys have watched Train to Busan. So in that movie, Busan is actually very safe from zombie apocalypse. Well, unfortunately, Busan is actually not safe from the impacts of tropical cyclone because it's a coastal city. So in 2003, tropical cyclone Mamie made landfall in Busan, and it is actually considered as the most powerful tropical cyclone to strike South Korea, like since record keeping, and it costed like damages for up to $4.8 billion, and it is also a Category 5 hurricane. So I think everyone knows that tropical cyclone are among the major natural disasters that could inflict the most damages to society and the economy. So let me give you another example. As you can see in this picture, it's a picture of a town that is very damaged because of tropical cyclone tropical cyclone Bofa. It's actually also a Category 5 cyclone, like the strongest tropical cyclone. That is actually my hometown. So in 2012, tropical cyclone Bofa or super typhoon Bofa made landfall in Boston, Davao Oriental, my hometown, and it took several lives, and it also took our home. Like we were homeless at that time. We lost our home, like completely damaged. Also in 2013, For Typhoon Haiyan, they said that it is actually probably the most or the strongest tropical cyclone ever recorded in history. It also made landfall in one of the coastal cities in the Philippines. So with a changing climate system, we know that the impacts of tropical cyclone will actually will be more severe in the future. Hence, it is very important to improve the understanding, the modeling, and the risk assessment of tropical cyclone. I know it's a bit different from the topics of the two speakers, so I hope you guys will still listen. And so in the academe, we actually use historical data gathered from gauge stations, satellite data, and like analysis data to investigate or to characterize the risk posed by tropical cyclones. However, with the rarity of tropical cyclones, for example, here in Korea, on average, they only experience 3 to 4 typhoons every year, and sometimes they don't actually experience tropical cyclone in a year. The data that we have is actually not enough to be able to get the full distribution of the risk that is brought by tropical cyclones. So it is very important to actually have more data, since the impact of tropical cyclone rainfall can be actually seen in the upper tail. And if you only have limited data, you cannot actually get their impacts. And most of the rainfall in the upper tail are the ones that are actually causing like extreme flooding or extreme impacts in the society. So this paved way for the introduction of synthetic TC modeling. So academics have decided to actually create models to generate TC tracks and also TC rainfall. However, most of the existing TC track model or TC rainfall model only utilize data from existing historical tracks. Only the tracks were utilized to create models. And they ignore the characteristic or the environmental impacts. For example, meridional wind, zonal wind, and generating synthetic TCs. So for our study, we think that it is very important to actually generate synthetic TCs using statistical approach, since when you use statistical approach, it will allow you to actually generate TCs of more than, let's say, 100 years, 1,000 years, but they still carry the characteristics of historical data. And we also need to consider the interaction between TCs and the environment when we want to generate tropical cyclone rainfall. Hence, for this study, we want to develop a semi-physical TC rainfall model that utilizes Markov renewal model to develop the TC tracks, and a physics-based rainfall model for the generation of TC rainfall. It's gonna be a bit technical, but I'm not gonna go through it. But I will just like give you an idea of what we did for this study. So for our study area, we actually consider the area within that domain, the one written at the bottom, and we use the data from the regional Special Meteorological Center (RSMC) BESROC data for the typhoon information, and the land surface and atmospheric quantities for the environmental information, and the Aphrodite data for the rainfall information. So this is the overall methodology. So the study started with generating TC tracks. So we used a Markov renewal model. So basically here, we utilized historical information from rainfall, for example, latitude, longitude, the wind speed, and also the environmental data, like for example, zonal wind, meridional wind, to generate TC tracks. So we are copying, or we're trying to make our own tropical cyclone tracks. And next is the generation of TC rainfall. Now that you have your own TC tracks, we want to know the amount of rainfall that each track will generate, or each TC will generate. So using the atmospheric data and the track data, we're able to compute the rainfall rate by using this formula, the one written here. And then after having our own rainfall, we were then able to conduct a rainfall frequency analysis, or we completed the rainfall for like 50-year return period, 20-year return period, or 10-year return period. So let's see the for track evaluation. So we divided our study into two different parts. First is the track generation, and then the rainfall generation. So first is the track generation. As you can see here, at the top part are actually the historical tropical cyclone for 40 years here in Korea. And then at the bottom part shown here are the generated tracks for 40 years using our model. Again, our goal is to not forecast real events. We are not trying to copy the exact events for the top part, but the goal here is to generate tracks that actually follow or has the same characteristics as the historical data. And as you can see here, for the left part are like simulation for 40 years, and the right part is a simulation for 10 years, so that you guys can have like take a closer look. So as you can see, our generated tracks actually follow the same or like general pattern of the historical tracks. So for example, most of the TCs generate at the eastern part of the Philippines, and they will travel northwest and then recurve to like part of Japan and Korea. And they also dissipate around North Korea and the upper part of Japan. This is the spatial distribution is quite similar based on the generated data. Next, here we divided our domain into 2x2 boxes. And for the left part, as you can see here, is actually we counted the number of tracks that originated, or the genesis. So I know genesis means like it originated, it started there. But since the study area is actually above the equator, and most of the thesis actually originate from the equator, like mostly from the Philippines, like around the Philippines. So here the genesis means the time that TC entered our selected domain. So for example, at the top part, as you can see the red part here, there are 20, meaning 20 TCs entered enter that domain. Or like 5 TCs enter that domain or enter that box when we divided it into 2x2 boxes. So for the top part, there are the historical data, and for the lower part, there are the generated data. And as you can see, for the genesis, our generated data was able to follow the genesis of the historical data. Most of the genesis actually occurs at the latitude lower than 25 degrees and around the longitude of 124 and 134. For the left part, this is the occurrences. So this time we counted the average number of theses that passed through the boxes. And as you can see, most of the boxes or most of the theses actually entered or passed through this path, like the area between the 30 degrees and 25 degrees, and also between 126 degrees, 128 degrees longitude. This is copied well by our model. This is captured well by our generated data. Similar result was also observed when we tried to extract the cumulative distribution function of the environmental data that we generated, and we plotted it against the cumulative distribution function of the historical environmental information. So, for example, the maximum sustained wind speed was able to was captured well by our model, as well as the other environmental factors. So now, considering all the results, we can say that our track model was able to capture the historical characteristics of the historical data. Moving on, let's go to the next part of the model, which is the generation of TC rainfall. So as you can see here is actually the track of during the onslaught of tropical cyclone Judy in 1989, and we also showed here the total amount of rainfall during the event. And as you can see, most of the rainfall is actually concentrated in the southern part or southeastern part. That's actually Busan. Again, Busan is a coastal area, so it is most like one of the cities that is most prone to the impacts of tropical cyclone. And as you can see, both the location and the magnitude of the observed TC rainfall are captured by the model. So now that we have proven that the TC rainfall, the TC track model, as well as the TC rainfall model, are effective in capturing the historical TC track and rainfall, we then simulated 100-year of tropical cyclone data and conducted a rainfall frequency analysis and compared the results when we conducted a rainfall frequency analysis using the 40-year data. So the observed here, again, as I've said a while ago, the observed here is the result after conducting a rainfall frequency analysis by only using the historical 40-year data. And then the orange dots here are the simulated data here are the results after conducting a rainfall frequency analysis using a 100-year TC events, like 100-year TC events generated using our model. So as you can see, our model was able to capture the return levels for lower return period. However, as the return period increases, we can see a big difference between the simulated and observed data. For example, in Seoul, if you will only use data using the historical values, you can only compute return periods after 50 years. But if you will use data for 100 years, you can actually compute return periods after 100 years. And these return levels, or these amount of precipitation for 100 years, is actually the most extreme. So it is really very important to utilize more than the historical data that we have right now. So a while ago, I only utilized Seoul, Pohang, Busan, and Jeju. But this time, we considered the entire South Korea. And as you can see, comparing the historical the results for the 10-year return period, if we only utilize the historical data on the left side, and for the 10-year return period, if we utilize 100-year data on the right side, we can see that our model was able to capture the distribution of the 10-year precipitation, especially here in Busan. It also gave us a correlation coefficient of 0.81. Now that we know that our model or our generated data could actually represent the historical data, we then conducted a rainfall frequency analysis for all the point of interest, the whole South Korea, without using the historical data. So here, shown here are the results if we will only use our generated data for 100 years. And as you can see, for the 20-year return period, most of the extreme rainfall is actually observed in the southeastern part of Korea. However, as the return period increases, we could see that the spread of heavy rainfall can now be seen even in the central part of South Korea. And also for the 100-year return period, even the western side, also the northern side, could now experience extreme rainfall events. So to conclude my study, we were able to develop a semi-physical tropical cyclone rainfall model that could actually mimic the distribution of historical data well for tracks and the rainfall. So we know that we're able to determine that the approach is effective in determining the spatial heterogeneity of these rainfall risks as the return period increases. So as the number of TC rainfall data increased, we're also able to get return periods that cannot be seen by only using the historical data alone. That's all. Thank you.
Thank you, Angelica, for how I say, it's very comprehensive. Yes, number one. Number two is quite insightful, because we always had the other side of other kinds of disasters happening. So having to have someone to talk about cyclone and all these data with the mapping, it's quite an intrigue. With that, I would like to also invite all our speakers now, Angelica, Giovanni, and also Nur Zaihan, to join with me to maybe to give, I don't know, let me check if there's any question, but last time I checked, there's no question from the audience. If anyone from the floor would like to ask any question to any of the one speaker, please do so. Click the microphone on and just speak away. In meantime, maybe I could ask one question based on the respective speakers. From what you've shared is actually based on your experience, based on your knowledge, based on your experiment that you're conducting. From all these findings that you have, what is it the key points that you think that you can convey to the person who is part of the policymaker, that it is some sort like a recommendation for them so that they could put in it's either local level or national level, in fact regional level. This is actually the key points that you need to do first in order to minimize the impact, minimize the disaster effects later on. So maybe you can enlighten us 2 points. Who would like to start first? Angelica, Joe, or Zaihan?
I can start first.
Okay, please.
For me, first thing come first, of course, human-centered disaster preparedness is very, very crucial. By looking at the increasing of the disaster frequencies nowadays, especially in the realm of climate change, human-centered disaster preparedness is very, very important. Why? If we, the researcher, the expertise, the policymaker, and everything doing our job, even a very great job, but the issues always be how we want to convey the knowledge or the research outcomes to the local people. So this is actually the challenge for us as the researcher, the policymaker, decision maker, and everything, to make sure that the outcomes of our research efforts can be translated in a very simple words or knowledge, to make sure that the local people who is actually the main victims in any kind of disaster can understand on how they want to like making their own preparations and everything, that kind of thoughts. So I think that would be my 20 cents.
All right, thank you for that. Before I give to Gio and Angelica, I see that we have Mr. Andy here. You know what, everyone, just to enlighten, why we having our session today is because it's in conjunction with KIWW, meaning Korea International Water Week. So we have 2 of our U-Inspire members. It has been our delegates over there. So maybe Mr. Andy, maybe 1 or 2 words, or maybe even say hi. I'm not sure whether you are able to talk with us.
Thank you, Dr. Ifa.
Yep.
The session's going great. I apologize, I'm in another session as well because of KIWW, but I have been listening to, and I think the presentations by Angelica and Azian and Giovanni are great, and it's something that the AWC platform needs as well. I think disaster risk reduction, especially things like coastal water management and tsunami awareness, and that it's not something that's particular to the Korean community where AWC is based. So I think this is something that needs to be considered, I think, in a more broader context in the Asian scope. So I think this is meaningful, even though, unfortunately, it's overlapping with KIWW, but I think this is something that needs to be incorporated on the Asian scale. I know Southeast Asia, this is very important, but more in Central East Asia and in the eastern part with Korea, and that I think not an issue per se. It's obviously in the case of Japan, obviously tsunamis and water disasters are much different risk, but I think in the Korean context, there's not much awareness. And this is something that I think, we on the AWC platform, we need. And so I think you Inspire and YPs in general can push these kind of agendas that are unique and very, not really niche, but they're on the large scale of SDGs and climate change reduction, disaster risk reduction. It's a very specific topic, tsunamis and coastal disasters, but it's important. And I think these presentations by young experts need to be disseminated and shared. So I hope after the session, we can get the recordings and share the information. And this is something that we need to disseminate to our AWC members. I think to especially intergenerational gap, there is a big gap between what is the current issues and what are the general issues. And I think this is greatly needed, and I appreciate it. So thank you so much. And thank you, Dr. Ifa and Hanif for preparing this, and the You Inspire team. I think it's meaningful and great. So great job, everyone.
Thank you, Andy, for a wonderful speech. Yes, this kind of platform, we actually maybe focusing towards where we live, especially in South Asia. Maybe we can go beyond on that. Maybe I'm not sure whether Andy can stay together with us. You are welcome to stay, but if you need to go, it's all right. But I would like to reflect what Andy just said, because I myself from Malaysia, so we actually have less experience in terms of disaster. So, but rather than being complacent in our place, I myself took the initiative to learn what the other part of the rest of the world is actually experiencing, so that we can actually share the experience and encounter more information and knowledge transfer going to happen. So I go back to both our speakers that have yet to have the key points of what they're going to recommend to the policymakers, because I can see their faces is very eager. They have a lot of ideas now. Maybe Jill or Angelica would like to take the floor now.
Okay, maybe I can share my recommendation.
Yes, please do.
I think I already put it in my recommendation, but I can mention it again that I agree with Kaan that that raising the awareness is important, but I want to add that further studies are needed, and I think the government still need to support, starting from the data, and then the funding or any program that related to disaster risk reduction, so that these studies can be done better in the future, and done by many other researchers. I think that's all from me.
Thank you, Jill. How about Angelica?
I actually agree with Gio, because I'm trying to study about the Philippines right now, and we're actually struggling to collect data. So I guess the support of the government, with that kind of giving data, giving assistance, will be very beneficial for us to be able to conduct more studies and to help our countries.
Well, that's good. Meaning, definitely I agree on that. With the correct data, we going to have a correct solution, correct pathway. And now people are actually talking about open data. There's no actually hidden or that need to be transparent, because with proper numbers, proper data, we can actually allocate the budget and vice versa and whatnot. So we have one question. This is from Hassan Musana. Is it from for Giovanni? Have you considered the coastal defense, such as coastal vegetation, that is potential able to reduce the height wave? Maybe you can clarify on that.
Yeah, thank you for the question, Hassan. But for my study, I did not consider the coastal defense due to the complexity of the modeling. So the model for the agent-based tsunami evacuation model is the simplest model that I tried to do months ago. But yeah, later, maybe I can try to put another complexity, including the roughness, the damage of the earthquake, the debris, and the tsunami damage as well, including this coastal defense. Thank you.
Okay, all right, thank you. I think I caught one question from the YouTube. It is for Anne. Do you think, what do you think or can be done to strengthening the partnership and networks at the coastal areas, besides from the local authorities and government?
Okay, because when we are talking about dealing with the local governance, local authorities, it takes a lot of paperwork, a lot of steps or stages to achieve or to complete the plans. So while waiting, we can plan for that, but we can do concurrent, which means as the community itself, we can plan our own preparedness strategy. Maybe like the people like us, which is like You Inspire Alliance, we have the youth disaster resilience, everything in like the NGOs and everything. We can do the plans with the community. That is what we mean by human-centered. We approach the local community itself and see what we can do to strategize the plans that the community can use it while waiting the official plans being issued by the local authorities or the guidelines and so on. Because when disaster come, there's nothing that we can do, and disaster not gonna wait for us to do anything. So we also cannot wait for that. We also cannot wait for the disaster to come. Only we can plan. So we have to strategize it from now on. We have top, bottom, bottom, top. So everything have to be worked on concurrently. I think, especially in the realm of the climate change, disaster can come and goes and lost anytime soon. So I think yeah, this is why the You Inspires here. This is why You Inspire being built, and also the rest of the NGOs and the communities, what activists and everything, so that we can work on our own first while waiting for the top persons to act.
Okay, thank you for that. If I capture that correctly, so basically how to strengthen the partnership is basically when we have a platform and also there's an integration. That is actually both what has been a popular comment or what you call suggestion from the scientists across Asia Pacific when I had a meeting last 2 weeks in Jakarta. But we know actually what's going on, what actually we need, but we need something to keep the engine on and keep on moving. We have another question. This one I'm open to Angelica and also Giovanni. Actually, I have this same question in my mind, which I'm going to ask next, but Harim stole the thunder. Can we combine Angelica's track evaluation and Geo's agent-based tsunami evacuation model together to complement each other research? What do you guys think?
I think Gio could actually answer that question.
I think it needs more studies. I think it will be possible, but yeah, I need to learn more because doing the agent-based tsunami evacuation model, the code is a bit complex. So that's why I didn't create the code by myself. So if we want to combine it using the Angelica track evaluation, yeah, I think we need to create it, start from the scratch, I think.
Angelica?
Yes, Dr. Rifa.
So okay, so basically you're agreeing or you have any other points you want to add?
Yeah, because like my study is about the rainfall, so the impacts it should be in Giovanni's side, like how could it affect tsunami? Yeah.
Okay, because I think if I'm not mistaken, the bathymetry data is also reflect from the rain data. So I think there's a bridge to combine Angelica's and also Joe's together. There's something combining these two. Maybe we need one more scientist to link together. Well, You Inspire is here. Welcome to corroborate after this. One more question. I think this will be the last one. Hassan Musana again for Angelica. Based on your research, are the coastal areas most vulnerable than other areas?
Yes, that's actually correct. So my study before that one, we investigated the distribution of TCs in South Korea, and the areas that are actually most vulnerable is the southeastern part of South Korea, which is the coastal area. Also, similar to the Philippines, all the coastal areas are very vulnerable to the impacts of TCs.
I see. All right. I hope the answers from the speakers answer all your concerns and your wonders. One final question from me. Whatever that you presented today, are you going or has been ever published in a journal or papers or anything? Do you have any plan, or is it published? Maybe Angelica, start first.
Yes, Dr. Ifa. I just submitted the revision of this paper to the Journal of International Climatology. Yes.
Maybe you can share the link, or maybe where we can can access to your research, as well as Giovanni. What's your end? Going to comment on that? Is it published?
Whatever that I shared today is like a debut in here.
Okay.
I haven't shared in anywhere, but I hope that with the collaboration with You Inspires, we can try to work papers on this topic.
Okay, thank you. And Gio?
Not yet published, but yeah, I'm planning to, because my supervisor asked me to do so.
Please do so. I'm looking for you to do that, and it's very, very interesting topic. And I see Andy raise hand. Yes, Andy?
I guess just based on the publication, this is something that I think UNESCO, IWCSM, and many organizations are interested in. Is, there's a lot of webinars and activity and discussion on various topics, but the actual publishing in like collectively, I think if we can get more youth involved and connect with experts and focus specifically on this topic, we could easily publish, and then by publishing, like a combination of multiple like research, and then summarize it and the risks and how we how we can move on and go to the next level to get attention from higher level like UN Water and other organizations to catch their attention and support, not only You Inspire, but youth in general. I think by disseminating the knowledge today, following up and sharing the information, I think it's the best way to get more interest. I think having more YP at this point is not as important as sharing the knowledge that you have and showing the visibility. So how to be visible and to connect, I think some kind of publication, whether it's a journal or something like that, but it could be published by You Inspire and sponsored by UNESCO or sponsored by AWC. That may be a way to raise awareness quickly, more effectively than just because even at AWC we have problems when we have webinars. There's no follow-up, but if you have an actual publication, that's kind of your core foundation for everything that you follow up on. And so I think from your You Inspire, it may be worthwhile even with AWC to just establish a specific group in Asia, just focusing on ocean and natural disasters and in ocean areas and coastal regions, and not so broad, not just DRR, but specifically about that. So like a working group within You Inspire that is not, you don't have to use You Inspire name, but it can be just the young experts in coastal region areas, reducing risks and disasters, things like that, and then disseminate it. That's just a suggestion, because I know there's a lot of interest for publications and raising awareness this way. So that if you're interested in that, we can definitely follow up and try to set up meetings with some of our AWC partners, because as I know, AWC, we have no real experts in this area. That we probably do, but we don't know, because it's very specific. But by having some kind of, this may be the best way. So just a suggestion.
Thank you, Andy, for the suggestion. I think that's a great offer. Initially, when we start with the Choco Talk DRR, meaning we talk about the DRR. Today, in fact, is our 12th times of Choco Talk DRR, meaning we have the past 11 session was we talk about something else, but focusing on DRR. So what we intended to do is actually to publish all these titles, all the findings, all the innovation that we had into one book. However, with your suggestion, I think we can always ask Angelica, Joe, and also Zaihan, in fact myself, going to write something to water related. Then we can publish, maybe AWC can see this is the outcome that we've conduct. Last couple of weeks ago, I have been selected in a team to write about a policy brief on coastal disasters. So that is also something that we really looking forward to. So as a young professional perspective, this is something interesting and exciting, but it will be meaningless if it's just only a verbal thing. So it will be better to be published and written, and so that the future can always refer what the things that we've done. So the next session is actually, oh wait, I think we have another question. Is from Ayu Surtiati. I think we can still open because we still have time. This one to Gio. Does tsunami drill or evacuation drill influence their behavior? Because the number shows the response is quite low, even though Tanjung Benoa has been affected by tsunami drill. Gio, maybe you want to respond on this?
Yeah, thank you for the question. Yeah, I actually asked them this question as well. So in the questionnaires, I also asked them, are they ever receive any tsunami or earthquake drill or trainings? And I found that 60% of them already receive such as the education or the trainings. Maybe that's why that I found that around 40% of them haven't received any intervention about tsunami preparedness or earthquake preparedness. I think that's what triggered the number of the response of the tsunami evacuation in my survey.
Thank you, Gio. I hope it's answered your question, Ayu. The next session is actually we expecting to have our Secretary General of You Inspire Alliance to give one word or two, but she's now in Bali having a physical meeting. So she conveyed to me to say thank you to everyone who participated today. Thank you to the speakers, Angelica, Zaihan, and also Giovanni for preparing wonderful material, for insightful material, and thank you, Andy, for giving the platform for us and the slot for us to conduct this event today. And I would like to also personally congratulate for the team who organized today, Hani, Firdaus, Eviana, Devita, Fajar, Elia, and I'm sorry if I miss any names. You have you guys a wonderful team, despite the challenges. We know every time of the event there's always challenges, but let me leave you today's session with maybe a slide of an insight in terms of do understand water. Water can be your friend if it is in small quantity, but it can also be a disastrous effect if it is in big large numbers, and it could be your friend, it could be your foe. So attend to it accordingly. With that, I think I would like to conclude for today's session. Before we do that, I would like to also invite all the participants who are here with us, who are still here with us, to open up your cameras, because we're going to have a quick photo session. This is going to be in a record. Everyone can please turn your camera on. Going to have a quick session. Okay, maybe after the count of 3, we can snap a photo. Maybe Hanif or Firdaus can help us to do so. Okay, give us the best smile that you have. In snap, going to be in 3, 2, 1, go on. All right. Do you need the second page? Yes.
Yes,
Good?
we do
Okay.
need. Yes, we do need.
Okay, now the second page. Ready, everyone? In 3, 2, 1. Is it done? Yes. Okay. Thank you very much. I see that our Secretary General is just here. Yes, just in time. We're actually concluding this. Maybe Dr. Rahma, if you can want to speak. Because we just conclude everything. The photo session is actually the commemorative of getting off of this event. Please welcome Dr. Rahma.
Thank you very much, Dr. Ifa. Thank you, Andy. Thank you, Angelica, Anne, and Giovanni. I'm sorry I couldn't follow the whole session, but I've been joining following your presentation on coastal hazard, which is really good. And I also want to send my condolences to Anne for bringing back your bad memory. But I think it is also important for us to keep remember from the survivors and moving better. Seeing the coastal hazard modeling by Angelica, I think it's also very common in the context of Asia, and the agent-based modeling by Giovanni. And I'm currently in Tanjung Benoa, where the agent-based simulation is taking place. So I think you will need another session with the people in Tanjung Benoa here, but we can definitely see that even though we have set up a public-private partnership, but still we need more effort to bring all the people safe. I would like to report a little bit from the international workshop on Tsunami Ready conducted by IOC's Indian Ocean of UNESCO, currently happening in Bali. We have also several countries from Asia, from the Indian Ocean countries, joining this workshop to build the Tsunami Ready community, which is in line, which is to the target to achieve the UN Decade for Ocean for the UN Decade for Ocean to achieve the safe ocean by 2030. So it is the same period of the SFDRR. And I think this year theme is early action, early warning, early action. So how we can also bring the scientific knowledge that we have into implementing to the local action together with the community and bridging the science policy nexus. We have the opportunity to mobilize more young people as well to build the readiness for coastal hazard. I think we are not talking only about tsunami, but also about typhoon. And it's interesting, like here, that the flood the inundation modeling, for example, in India, is also based on the from the typhoon, from the cyclone, and also for the tsunami. So I think all the three speakers here are really complementing each other about the coastal hazard. And I hope that we, the U-Inspire Alliance, together with all other young professional networks in Asia Water Council young professionals, can continue working together and sharing knowledge. And maybe we can sometimes implement action to the community together as well. But I think all the scientific knowledge is very important to provide very good action to the community. So again, thank you. And Andy, thank you very much to move this forward. And I hope we can still conduct another session together in the upcoming years. Thank you very much again, everyone. Hanif, thank you very much for organizing all this.
Thank you, Dr. Rahma, for a really concluding speech on that. I think that will be it for today. Thank you for having us. Thank you for joining us, and thank you for being with us about 1.5 hours for today. I hope that we're going to see you for the next Choco Talk. We're going to announce the topic for the next one. Please follow us on our social media, because that is how we move. So thank you and have a nice day. Goodbye. Assalamualaikum.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone.
Thank you, Dr. Rama. Thank you, Hanif.
Thank you, Hanif. Thank you,
Thank
Dr.
you.
Rama.
You-Inspire Alliance is a network of youth and young professionals working in science, engineering, technology, and innovation.
You-Inspire Alliance provides the platform for youth and young professionals to connect, engage, and learn from other youth and experts in the region.
We are not only at the international conferences or at the laboratories. You-Inspire is working together with the local community in the field.
Our main objective is to provide a platform for youth and young professionals to participate in problem-solving actions towards disaster risk reduction.
To participate in decision-making, demonstrating their ability for advocacy, communication and consultation, as well as leveraging advanced technology.
We strongly believe that inclusivity is the integral factor of the DRR. Hence, all our work and projects are people-centric and from the communities on the ground.
We are committed to supporting youth leadership. We are happy to work with the You-Inspire Alliance.
You-Inspire Alliance bridges the gap between professionals and young specialists and make it possible to exchange knowledge and experience between Asian countries to make them more resilient.
We work with youth and the young professionals from the academe and the industry sectors to build back better in a post-pandemic world.
You-Inspire has connected us and bring us together to contribute for disaster risk reduction and climate change by utilizing science, engineering, technology, and innovation.